Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we had discussed the factors of resistance. Okay. So now I'll ask. Okay. So what are the factors of resistance of a conductor? So please put that factors in your comment box. Okay. First, the factors of resistance. What are the factors of resistance? So put your answer in the comment box. Quick. Yes, what are the factors of resistance of a conductor? So first one, yes, the length of the wire or length of the conductor. First one is. Then second one, resistance is directly proportional to the length. That is over. Okay. Yes. Next one. Next, length of the conductor. That is over. Second one. So first factor is the resistance of a conductor depends on the length. Okay. Then second property. Second one, area of cross section of the conductor. Very good. Okay. Then third one. Then third one. Yes. First one is length of the wire. Second one is area of cross section. Then third one. Third one first. Yes, third one is nature of the material. Very good. Okay. So factors of resistance. First one is length of the conductor. Second one, area of cross section, and third one, nature of the material. Okay. So now for example, first one, length, right? Length. So if you increase the length, what will happen? When you increase the length of the wire, then the resistance increases. So that's why clearly we can say that the resistance of a conductor is directly proportional to the length of the conductor. Okay. So now call this equation as 1. So resistance is directly proportional to length. Why? Because when you increase the length of the wire, the resistance of a conductor increases. Okay. So in the previous class we had discussed how it increases when you increase the length of the conductor. Okay. Next one. When you increase the area of, say, the next property is area of cross section. When you increase the area of cross section, at that time what will happen? So clearly we can say the resistance of the conductor decreases. When you increase the area of cross section, then resistance of the conductor decreases. So that's why we can say that, or we can write resistance of conductor is inversely proportional to area of cross section. Inversely proportional to area of cross section. Okay. So now combine these two equations 1 and 2. So we can write clear. We can write like this. Okay. The resistance of conductor is directly proportional to the length of the wire and inversely proportional to the area of cross section. Okay. So now write this symbol, constant of proportionality. So to remove that, we should introduce one constant, right? So in your in the 9th slide, we have studied while deriving F equal to ma. Okay. So here now we can write R is equals to rho into N by A. Okay. See, this is new term. Just observe this one. What is that? It's rho. Okay. Rho means what? Here this rho is constant of proportionality. Okay, so you know while studying F is equals to ma, F is equals to ma, you have studied right this equation. M is direct proportional to mass and acceleration. Then you have introduced one constant, that is k. Okay, and in gravitation chapter you have studied this one, g into m1 into m2 divided by d square. Okay, hope you remember. So now also here to remove this proportional symbol, so we have introduced one rho, one symbol. Okay, so the name of that symbol is rho. Okay, so that rho is called constant of proportionality, which means, see, this symbol represents, this constant of proportion represents the specific resistance of the conductor. Okay, what is this? What is the meaning of this row? That row indicates the specific. Okay, so listen carefully that word. This row indicates the specific resistance of the conductor, which means, see, if you take some conductors, they have some kind of minimum resistance. They have some kind of minimum resistance. So that minimum resistance is called rho. Okay, or resistivity. So clear it, resistivity means what? Resistivity means it is the specific resistance of a conductor. Now see here. See here. So now just to take I'm taking copper wire. Copper wire. Okay. See, length is 1 meter and area of cross section is also 1 meter square. Okay, so length is 1 meter and area of cross section 1 meter square. Okay, so now here I pass electrons to this wire. Okay, so clearly we can say when the while moving electrons from this end to that end, so definitely they will oppose some kind of opposition. Okay, they will face some kind of opposition. Clear? So here, while passing electrons from one end to here end, you will get some opposition, right? So that opposition means what? So we call it as a resistance. Okay, resistance. So you will get here resistance, right? Okay, here you will get one value. Okay, so this, because see here I have considered 1 meter and 1 meter square. Okay, so here while moving electrons, they will face some kind of resistance. Clear? So that resistance is called resistivity. Are you getting my point? Resistivity is nothing but it is also resistance, but it is specific resistance. What is that? Specific resistance. Okay. See, all the conductors they have minimum resistance. All the conductors they have some kind of resistance. See, if you take copper, that is different. It has a different resistance. If you take aluminum, that is different because the flow of opposition in copper is different, in aluminum is different, in gold different, in silver different. Why? Because the arrangement of particles are different in these elements, right? Or in these conductors. So that's why the flow of opposition is different. But flow of opposition is there. Okay? But flow of opposition is there. Okay? So here to calculate that resistivity, we should consider length of the wire of the conductors as 1 meter, then area of cross section as 1 meter square. So now here I have taken copper, right? So next I will take silver or take aluminum. I will take aluminum. Here also length 1 meter and this is also 1 meter square. So now here in this case here I have considered 1 meter wire length and 1 meter square area of cross section. Here what you will get, that resistance value. Here you will get resistance value, right? So that value is called resistivity, which means the resistivity means it is the specific resistance. What is that? Specific resistance, which means if you take one conductor, it will have some kind of appreciable resistance. Okay, that appreciable resistance is known as resistivity. And here we should consider, see, to calculate the resistivity of the any conductor, we should consider length of the wire as 1 meter and area of cross section as 1 meter. Clear? So here we should consider what to calculate resistivity. Resistivity of any conductor. So we should consider length of that conductor as 1 meter and area of cross section as 1 meter square. Okay, so remember in the previous class also I have told already what all the conductors they have some kind of appreciable resistance. Okay, so that means they have some kind of resistance. So that resistance is called specific resistance. Next, then now I will increase. Okay, I will increase this length of the wire. Okay, at that time you will get resistance but different value, right? At that time we will call that as resistance. Okay, if the length is 1 meter and area cross of 1 meter is, instead of resistance we will call resistivity. If you increase the length or if you increase the area of cross section, then you will calculate that of flow position, right? So at that time we will call that as resistance. Okay, see, resistance and resistance both are same, but resistivity means what? It is a specific resistance. It is a specific resistance. Take one simple example. Sharbat. Okay, just imagine. If you taste that sharbat in a spoon or in a cup, if you taste that sharbat in a spoon or a cup, but the quantity is different in a spoon and a cup, what about the taste? Taste the same, right? Okay, so here also if you take the length, let's say if you take the 1 meter length or 2 meter length or 10 meter length of the conductor, but if whatever you can take the length or area, but some kind of resistance exists in that conductor, okay, or some specific resistance exists in that conductor, that specific resistance is called resistivity. Okay, so to calculate resistivity, first we should consider length of that conductor as 1 meter and area of that conductor as 1 meter square. Okay, when you consider 1 meter length and 1 meter square area, at that time you will calculate some that resistance, right? That resistance is called resistivity. When you increase the length and the area of cross section, then we will call it as resistance. Okay, so resistivity means what? It is a specific resistance. It is a specific resistance. Okay, see here. So here now this is R means resistance, resistivity, length and area. Okay, first I will bring the area length this side. See here. R into area divided by length is equals to rho, or rho is equals to length into area divided by L. Okay. So now, what is the SI unit of resistivity? You know, right? What is resistivity means? It is the specific resistance or minimum resistance. Yes. So what does it's not P? Okay, it's a rho. Rho stands for in this formula here. See, it's not P. It's we call it as rho. Okay, rho means resistivity. Clear? Already know, right? What is resistance? It is the specific resistance of the conductor. Okay. Now, see here. Rho. See, resistance we measure in ohm. Then area meter square. Length meter. So meter cancel. Then remaining becomes ohm and meter. Okay. So the SI unit of resistivity is ohm meter. Are you getting my point? The resistivity, the SI unit of resistivity is ohm meter. Clear? Ohm meter. Okay. So here the resistivity means it is a specific resistance. What is that? The specific resistance of the conductor. Okay, so here we will consider to calculate the resistivity of the different conductors. We should consider length of the conductors as 1 meter and area cross section as 1 meter square. Okay, at that time we will calculate some resistance, right? That resistance is called resistivity. Okay, next. See, in your textbook they have given the different value for resistivity for different conductors. The resistivity of silver is, that is resistivity of silver, okay, that is 1.6 into 10 raised to the power minus 8 ohm meter, minus 8 ohm meter. So in your textbook they have given the list of some of the conductors. Okay, see they have calculated that resistivity values. Okay, to calculate that one they have considered length of the conductors as 1 meter and area of cross section as 1 meter square. Okay, for see they are given right, silver, copper, aluminum, tungsten, nickel, iron, chromium, mercury, manganese, and other some glass, hard rubber, and diamond. Okay, here they have considered length of all the conductors as 1 meter and area of cross section as 1 meter square. Then they got that value. Okay. Here conductors they have very least resistivity. Why? Because conductors are easy path for flow of electrons, right? Then what about insulators? Insulators. So insulator means, for example, glass, hard rubber. Okay, there is no movement of there is no movement of electricity in the insulators. Okay, so insulators they have high resistivity. Okay. Next, see there alloys. Alloys means it's a mixture of two or more elements. For example, manganese, which means it is a mixture of copper, nickel, and manganese. Okay, manganese. See, especially we use alloys in heating devices like iron toasters and electric bulbs. Okay, we use alloys. We use alloys. Alloys means what? It is a mixture of two or more elements. Okay, here one given the example, that is manganese. What is that? Manganese. It is a mixture of copper, manganese, and nickel. It is a mixture of copper, manganese, and nickel. Okay. See here, in the heating devices like iron, toasters, and electric bulbs, we use these alloys. Why? Because alloys they do not burn or they do not oxidize at high temperatures. Are you getting my point? This is very very important. They will ask why alloys are used in heating devices. Okay, why we use alloys in heating devices? Because they do not oxidize or they do not burn readily at high temperature. Okay, you have seen like this kind of bulb. Okay, instead they use some kind of tungsten like this. Okay, see instead of this tungsten, if you use copper wire, here what will happen? See when you pass a 250 voltage, 220 to 230 voltage, that copper wire will burn. Okay, here, so that's why here here we are using tungsten wire, right? Why? Because it holds that temperature. It has a capacity to hold that temperature. So that's why we use alloys in heating devices. Okay, because they do not oxidize or they do not burn easily. So that's the reason. That's the reason why we use alloys in heating devices. Okay, so this is very very important. Why alloys are used in heating devices like electric iron and toasters. And see, copper and aluminum wires are used. We will use for that one electrical transmissions. Okay, for electrical transmissions we use aluminum and copper. But iron is also good conductor, right? Okay, this is also good conductor, but we do not use this one for electrical transmission lines. Okay, so now can you give a reason why we can't use this one for electrical transmission lines? Instead of this one we use copper and aluminum wires. Okay, we won't use this one. Why? Yes, please give the reason for this one. Okay, yes, tell me. Give the reason fast. Why we can't use iron for electrical transmission lines? Okay, for electrical transmission lines we use copper and aluminum wires. Okay, so we can't use this one. Why? So because it is Okay, other reason because its malleability is less. Then simple reason is there. Okay, so give that very simple reason. It generate more heat. Iron gets rusted. Very good. Iron gets rusted. You know, right? When it is, I think you are in Karnataka language we call it as tukku hidiyodu. Okay, that is corrosion. Due to the corrosion, okay, it loses its property. Correct? So it loses its what size. So that's why we can't use this. We can't use iron for electrical transmission lines. Okay. Next. Okay, so next move to directly we'll move to the problems. Hope clear that resistivity, the difference between resistance and resistivity. Okay, see, resistance means what? It is a flow of opposition. Resistivity also is a flow of opposition, but in for that one it is a specific resistance. What is that? It is a specific resistance of the conductor. So factors of a resistance, one is length of the conductor, then factors of the factors of a resistance. First one is length of the conductor, area of cross section, then nature of the material. Then what are the factors of the resistivity? Factors means when it changes. Okay, you know, resistance, when you change the length, the resistance changes. When you change area of cross section, then resistance changes. When you change the nature material means if you bring instead of copper, if you bring the aluminum, then also resistance changes. Okay, then what are the changes? What are the factors of resistivity? Yes, tell me what are the factors of resistivity? Put it in your comment box. Factors of resistivity. Factors means what? When that resistivity changes, and when changes means what? When it increases and when it decreases. Okay. Yes. What are the factors of? No. When the area increases, resistivity increases. No. When you increase the area, then resistance increases. Right. I have told what is resistivity. Resistivity means what? It is a specific resistance. If it is the specific resistance means here will come to 1 meter length and 1 meter area of cross section. When you increase the area of cross section length, then later we use the resistance word. We won't use that resistivity. Okay. So what are the what are the factors of resistivity? See, resistivity means what? It is a flow of opposition. When the length of the conductor is equal to 1 meter and area of cross section is equal to 1 meter square. Okay? Fast. So think and tell me. So factors of resistivity. When we change nature, yes, correct. Nature means nature of its material. Okay, see, resistivity is different for aluminum and different for copper and different for iron and different for nickel. Correct? Why? Because the flow of opposition, when you consider length as 1 meter, area as 1 meter square, at that time the flow of opposition is different. Okay, so first one, what is the first factor of the resistivity? Nature of its material. Then one more is temperature. Okay, in the previous class I have told, right? The factor, one more factor of resistivity is resistance. Okay, for example, you know, just imagine if you are doing an experiment in a room A. So here you will consider 1 meter length and 1 meter square. Just when this is a copper wire. Okay, so here you will get some resistivity, right? Now in this room, say temperature is 35 degrees Celsius. You are using the same wire, same length, same area of cross section. You are doing the same experiment in B room. Okay, so here the room temperature is 40 degree. See, while doing here you will get some resistivity, right? Here you will get some resistivity, okay, but you won't get the same resistivity here also. Why? Because here the temperature changed here. Okay, here temperature is 35 degrees Celsius and here 40 degrees Celsius. Okay, so the flow of propulsion is different in both the rooms. Why? Because the temperature changed. So now tell me, when you increase the temperature, the resistivity increases or decreases? Yes, please give the answer for this question. Okay, when you increase the temperature, at that time resistance increases or decreases? Quick. Yes, then the resistance increases. Very good. Okay, when you increase the temperature, then resistance of the conductor increases. See here. So consider one wire. Okay, you know here particles are arranged here, atoms. Okay. See, when you heat the wire, what will happen? See, before heating, all the electrons are simply they are revolving around the nucleus. When you heat the wire, what will happen? Then they will see, they will vibrate or they will revolve with high speed, right? They will gain some kind of kinetic energy from that heat. Okay, then they will vibrate very speed. Okay, so then it is a little bit difficult for electrons, when you pass electrons or when you pass voltage, to move from here to here. It is a little bit difficult. Why? Because these electrons are vibrating very rapidly, means the vibration speed increases. Okay, so that's why when you increase the temperature, then resistance of the conductor increases. Okay, so next we'll discuss some problems. First we'll discuss some simple problems. Okay, see here. First one. Find the resistance. Find the resistance. Find the resistance of a nichrome wire. Nichrome wire of length 1 meter and area of cross section 2 millimeter square. Okay, so the resistivity of the resistivity of nichrome is 100 into 10 raised to the power minus 6 ohm meter. Okay, yes, see here, find the resistance of a nichrome wire. Find the resistance of a nichrome wire of length 1 meter and area of cross section is 2 millimeter square. Okay, here it is in 2 millimeter square. Then the resistivity of nichrome wire is 100 into 10 raised to the power minus 6 ohm meter. Yes, first write the given data. So length, that is 1 meter. Length is 1 meter. Then area of cross section. Okay. So A is equals to 2 millimeter square. Yes. Now convert into millimeter into what? Meter. Okay. Yes. How to convert? Convert into millimeter into meter square. Milli means what? Milli means 1 by 1000, right? Okay, milli is equals to 1 by 1000, or we can write this as 1 by 10 to the power 3, or we can write 10 raised to the power minus 3 meter square. Okay, see, listen here. If you want to convert into millimeter square, here milli means what? 10 to the power minus 3. So just write 2 into 10 raised to the power minus 3 m square. Okay, 2 millimeter square. And one more here, see millimeter square, right? Which means both. Okay, it is just like this millimeter whole square actually. Instead of we'll write like this millimeter square. Clear? So here we should write. We should take here. Say millimeter square. So we should take the square here. 2 into 10 raised to the power minus 3 into square. That is meter square. We can write this as 2 into 10 raised to the power minus 6 meter square. Okay. See, actually milli means what? 10 to the power minus 3. But here millimeter square is the right millimeter square, which means 10 to the power minus 3 square. 10 to the power minus 3 square. Then it will multiply 3 into 2. You know, write this formula. A to the power n to the power m is equals to a to the power n into m. Okay. So now rho value is 100 into 10 raised to the power minus 6 ohm meter. Rho is equals to 100 into 10 raised to the power minus 6 ohm meter. Okay. Yes. Now tell me the answer. We do the formula, that is R is equals to rho into length divided by area. Substitute the values and give the answer first. So 50 ohm resistor, very good. 50 ohm resistor, 50 ohm resistor. Okay. Only 2 students answered. What about others? Yes, 50 ohm. Okay. See here, you should know this one. Okay, here why you should know why here we have taken square. Why? Because it is millimeter square is there. Okay. So millimeter square means we should take the square for milli. See here now. Substitute the values. So rho is 100 into 10 raised to the power minus 6, and length is 1 meter, and area of cross section is 2 into 10 raised to the power minus 6. Clear? See, while multiplying 100 into 1, you will get the same answer, right? Okay. So I will write here. So 100 into 10 raised to the power minus 6 divided by 2 into 10 raised to the power minus 6. See here, both minus 6. Both are cancel each other. Okay. Then remaining is R is equals to 100 divided by 2. So that is you will get 50 ohm, because the essence of resistance is ohm, right? So what is the answer? That is 50 ohm. Okay. Yes. Next one. Next one. See here. Find the resistance of a nichrome wire of length 1 meter and area of cross section 4 mm square. Okay, 4 millimeter square. And so resistivity of that nichrome wire is 100 into 10 to minus 6. Yes. Find answer for this question. Very simple. Okay. So when it was 2 meter, will give you have got 50 ohm. So now it is 4 millimeter square. Yes. 225 ohm. Yes, exactly right. Okay, no need to calculate. Everything is same. Only here, see, earlier it was 2 millimeter square. Now it is 2. Sorry, now it is 4 millimeter square. Okay, so definitely you get 25 ohm. So first length is 1 meter, then area of cross section is that is 4 millimeter square, right? 4 millimeter square. While converting 4 into milli means 10 raised to the power minus 3 whole square into meter square. So that is 4 into 10 raised to the power minus 6 meter square. Then the resistivity of that nickel nichrome wire is 100 into 10 raised to the power minus 6 ohm meter. Okay. So we know the formula R equal to rho into L by A. By substituting 100 into 10 raised to the power minus 6 into 1 divided by area of cross section is 4 into 10 raised to the power minus 6. Okay, cancel. So 4 ones are 425s are right here. Finally, you will get R equal to 25 ohm. Okay. Yes. Next one. Find the resistance of a copper wire. Okay, find the resistance of a copper wire that is okay, 1 meter only. So find the resistance of a copper wire of length 1 meter. First I erase this one. Wait. So copper wire that is of length 1 meter and area of cross section is 2 millimeter square. The resistivity of a copper wire. The resistivity of a copper is the resistivity of a copper is 1.7 into 10 raised to the power minus 8 ohm meter. Minus 8 ohm meter. Yes. Find the answer for this question. Okay, here you should calculate the resistance of the copper wire. Find the resistance of a copper wire of length 1 meter and area of cross section 2 millimeter square. The resistivity of a copper wire is okay. Just add here. The resistance of the resistivity of a copper wire is copper wire is 1.7 into 10 raised to the power minus 8 ohm meter. Yes. Find the answer for this question quick. Okay. Just tell me what is the answer for this question. Yes. First length is equals to 1 meter and area of cross section that is 2 millimeter square. So convert into meter. We will get 2 into 10 raised to the power minus 3 whole square meter. So finally we get 2 into 10 raised to the power minus 6 meter square. Okay. Then resistivity of the copper wire is that is 1.7 into 10 raised to the power minus 8 ohm meter. Yes, we know the formula. That is R is equals to rho into L by area, length by area. Okay, then rho is 1.7 into 10 raised to the power minus 8, and the length is 1 meter. Length is 1 meter. Then here it is 1.7 into, sorry, area, right? Area is 2 into 10 raised to the power minus 6. Okay, so when you multiply one, you'll get the same answer, right? So 1.7 into 10 raised to the power minus 8 divided by 2 into 10 raised to the power minus 6. So first take this 10 to the power minus to the upper, to the numerator. So you will get R equal to 1.7 into 10 raised to the power minus 8 into, now here it will become 10 to the power plus 6. Why? Because here we are taking from denominator to numerator. At that time sign changes, right? It is minus. So what happens when you go to numerator? So its sign changes to positive, from negative to positive. Okay. Yes, just observe here. A to the power m into a to the power m is equals to a to the power m plus n. Use this formula. Okay. And here this is divided by 2. Right here. So R is equals to 1.7 into 10 raised to the power minus 2 divided by 2. So better here into 10 divided by 10 to remove this dot, okay, of that decimal into. So R is equals to 17 into 10 raised to the power minus 2 divided by 20. Yes, do it and find the answer for this question. Okay. Yes, tell me what is the answer. So that is 0.8 into 10 raised to the power minus 2. 0.8 into 10 raised to the power minus 2. Yes, you are right. Okay. See, just divide 17 by 20. Keep that power as it is. No problem. Nothing will happen. Okay. First, okay, while dividing, so I'll write directly. We will get right here. While dividing 17 by 20. So keep that time ratio minus 2 as it is. Okay. So we will get R is equals to 0.85 into 10 raised to the power minus 2 ohm. See here, earlier we got 50 ohm and 20 ohm for nichrome wire. Okay, so now here we got 0.85 means see less than 1. Less than 1. So what it indicates? Which means that nichrome wire, it has more resistance. It has more resistance, and copper wire, it has very less resistance. Why? Because copper is a good conductor, right? So electrons, so copper conductor, it is a very easy path for the movement of electrons. And what of copper wire, it is little bit difficult. Okay, why? Because there is a more resistance in the nichrome wire. Okay, so I will stop here. Tomorrow I will continue the class. Thank you.